name is Erica Goldberger. I'm a robotics solutions architect at AWS. So I help robotics companies with their AWS cloud infrastructure. I've been with AWS about 3.5 years, and prior to this role, I worked for training and certification, building some of our courses. So I do recommend you check out AWS Skills Builder. We have a lot of trainings there. And I work out of Boston, which is a great hub for robotics. I don't know if anyone here is from Boston. Yeah. Awesome. And yeah, so I'm going to discuss patterns for cloud-enabled robots. And I just want to get a better idea of who's in the room here. How many people here work for robotics companies? No? Okay. How many people work for companies that are building robots or thinking about building robots? Okay. All right. And how many people are here just because robots are cool? All right. Sweet. That's awesome. That works too. Yeah. Companies that use robots. Anyone else? No. All right. Okay, so quick agenda. We're going to talk about some patterns for deploying to robots, streaming video to robots, and then training and deploying machine learning models to robots. So before we get into some of those patterns and solutions, I want to talk about some challenges in the robotics industry. So the first is that building robots is capital intensive. When you want to get started building robots, you need all the hardware, the sensors, the compute, the GPU, all of that. But then in addition, you're building the robots for some sort of purpose, right? And so you need some sort of physical testing environment. Maybe you need maybe you're building fulfillment center robots, right? You need some fake fulfillment center to test your robots. So all of that could be very expensive. In addition, there's a big skills gap. The robotics industry is relatively new, and you need people with skills in hardware and software, maybe now cloud skills. And so I guess it's a good thing that we got a lot of people interested in robots in this room, because we need to fill that skills gap in the robotics industry. The third is business use cases. It's hard to find the right product market fit with robots. On the one hand, right, robots could be used to automate anything, so it could go to a lot of different industries. But many companies and industries are just very slow to adopt new technologies, and enterprise sales cycles can be long. And last is robot operations. So it could be pretty complicated to deploy and manage large fleets of robots, and to go from that prototype stage to the production stage, and go from those small testing environments to production. For the few in this room who are deploying to robots, do any of you have specific challenges when it comes to deploying to your robots? Are they remote connected? Or do you have big fleets that you need to manage? All right, so I'll bring in an example from one of our customers. So one of our customers is AgroIntelli. It's a startup based in Denmark, and they build cloud-connected agriculture robots for precision farming. And their robots run on farms, so they're remote locations and not always connected to the internet. And technical visits to update or troubleshoot these robots can be very time-consuming and expensive because you have to drive all the way out there. So AgroIntelli solves this by using AWS IoT Greengrass v2. And that's an open source edge runtime, and it helps customers build, deploy, and manage device software. So many of our robotics customers are moving to use Greengrass v2. So I want to dive a little deeper into this pattern and how our customers are using it. All right, and I'm going to mention Greengrass v2 is one of our AWS IoT services, and I'm going to focus specifically on the benefits as it relates to robotics, but it does have benefits outside of that. So Greengrass will extend your AWS services to the edge onto your devices, so they could act locally on the data, but also still take advantage of the cloud. And here are a few of the benefits. I'm not going to read through these because we'll get into them in further detail. All right, so Greengrass manages software running at the edge in what's called components. And these are modular and flexible units. And these components can represent applications, runtime installers, libraries, or really any code that you want to run on your device. And this could include the robot operating system ROS applications or Docker containers. For the duration of this presentation, the component's going to be represented by that green circle with the arrows. So those are the Greengrass components. And so after a simple provisioning command, Greengrass creates and manages the permissions that software components can use to connect to cloud-based services. So you could do over-the-air updates, and then Greengrass also comes with built-in features for data and state synchronization, data stream management, machine learning inference, and more. And we're going to get into some of these examples. Okay. So what you're looking at here is an architecture. So on the left, we have what's happening in the cloud, and on the right is on your robots. And so with Greengrass, all of the actions are available through an API, and you can integrate it with your CI/CD pipeline. So as you test and are ready to, you've built and tested your components, your applications, and hopefully you decompose them into microservices, small modular components. You could deploy them to your fleet of robots. And the Greengrass agent is running on your robot, right on the edge, and it's going to receive the update, and it's going to manage the local software application cycle, so the start, shutdown, and recover. And then once deployed, Greengrass can run your components offline for long periods of time. So if you don't have connection, that's okay. It will still benefit from these components, and they'll be able to continue running up until you want another update, another deployment coming to your robots. Any questions thus far? All right. So as anyone who's deployed code to robots, or really any code, there's always going to be errors, issues, things that go wrong. So Greengrass has these knobs and dials, so you could have failure-resilient deployments. So you could set a configurable deployment rate to deploy to a limited number of robots. So you could start by deploying to 5% of your fleet, then increase 10%, 20%, all the way up until you're deploying to 100% of your fleet. That way, you reduce the blast radius if something does go wrong. You could also set failure thresholds. So you could stop the deployment if, let's say, 20% of your deployment fails. You could also set timeouts in the event of if a robot's not receiving the update. And then you could do rollback policies. So if a new update is not going as planned, then you could roll back to the previous version of the component. And then lastly, you could set up conditional update workflows. So Greengrass has event hooks that could run validation checks before deploying a component. So you could say, hey, my robot is in the middle of doing robotic surgery. I do not want to deploy an update right now, right? Or even just my robot has low battery. I don't want to deploy an update right now. You could set those conditions and set a condition so that the deployment does not go through during those times. So Greengrass comes with some pre-built components to speed up development. And these pre-built components are common functionality that many of our customers use. And I have a few examples here around machine learning and streaming data, but we have more than 20 components. It's probably more than that at this point in time. That you could deploy right to your robot, and some of them have configuration, and some of them you could just deploy right to your robot. We also now have community components. So AWS community members have created components that are open source, and you could deploy to your robots as well. All right, so here we are back with AWS Cloud on the left-hand side and your robot on the right-hand side. And so here we have some custom components in green here. So these could be your ROS applications or Docker applications. And alongside those components, you could also bring in these pre-built components. So you could bring in, for example, machine learning inference for having machine learning at the edge on your robot. You could also bring in secure tunneling, so you could troubleshoot your robots or for supervision. You could, we have a pre-built component stream manager for streaming data into the cloud. And then we also have community components related to video streaming for capturing live video and managing WebRTC channels. And then once you have all this data, you could then take advantage of the cloud, right? Now all of this is in the cloud. You have your data in the cloud. You have your video in the cloud. And maybe you want to create a web application for your customers or for your robot fleet managers that are on site. So you could use AWS Amplify to then pull that all together and build an application for them. And so this is kind of at a high level what your application might have. OK, I want to pause one more time, see if there are any questions. Yeah?
During deployment, if 3 steps are there and it failed at step 2, would it come back to the original state?
So the question was, if you're deploying and there are 3 steps and it failed at step 2, would it go back to the original state? Yeah, so it depends on what type of failures, but you can set it up that way so that it does roll back and waits till the end, and then we'll make sure everything is working, and if not, roll back. Any other questions? Yeah.
General question, if the robot is not connected, how do you kind of provision the behavior of the new software?
Yeah, so you do need connection for the deployment. Once the components are deployed, oops, I'm not going forward here. There we go. Once the components are on your robot, then it could act with those components. And so like the machine learning inference will continue to happen at the edge, but if you wanted to deploy a new machine learning model, that you need to connect to the cloud for. There is a way to also deploy components locally, but then you would have to directly access the robot. Okay. So we have a few different patterns we could dig into next, and I'm kind of curious what the room is most interested in. So we could talk more about ROS applications with Greengrass and the different patterns that you could deploy there. We could talk about machine learning with Greengrass or video streaming. So show of hands, who prefers ROS deployments on Greengrass? All right. Machine learning? OK. And video streaming? All right, cool. Hopefully, I think machine learning had the most, but we should be able to get to all of the above. OK, I'm just going to skip ahead, and we'll come back here. All right, so over here we have an architecture that we built with Boston Dynamics for their Spot robot. And the Boston Dynamics Spot robot is frequently used for autonomous inspection, so maybe to discover leaks or read gauges or evaluate conditions and run safety compliance checks. And they're often running in difficult or dangerous locations disconnected from the cloud, like construction or industrial sites. And so we partnered with Boston Dynamics to create and run a cloud-trained machine learning-enabled application using Greengrass. So Greengrass is running on their Spot robot. And this machine learning model is using computer vision to detect objects like fire extinguishers so they could see when they're expired. And so initially, we captured raw training data from the robot, and then we used Amazon SageMaker ground truth to handle data labeling. And then we trained our jobs in the cloud and created a model. And then from that model, we deployed we did inference on the edge with Greengrass, and we used the public component there. And you could see that's being deployed alongside a few other components. So in this case, they're actually using Lambda components. So AWS Lambda is our serverless service, and you could deploy Greengrass components via Lambda. So you could write a Lambda function and then deploy them to your robot. So here they have code to connect to the Spot SDK that Boston Dynamics created. And this will all run on the robot. And in this case, it's running, Greengrass is running in a Docker container on the host, the Spot robot. And then it's connecting to a Spot tablet. So I could play a quick video here. I'll come back to that slide. So this is from their tablet for the Spot robot. And so it's just detecting objects in view. So in production, the way this would look is there would be, fire extinguishers, and they'd look at the expiration dates, and you could put that into a workload where it sends SNS notifications to inform the relevant people that it's expired. I'll go back to the previous slide here to look back here at the architecture. Right, so machine learning model and training happening in the cloud, and then inference is happening at the edge. Any questions here? Yeah.
So are you controlling the robot from the tablet, or is it doing it itself?
So in this case, the Spot robot, I think, was just being controlled from the tablet because this specific architecture and workload was just for the computer vision aspect. But you can, create a different model where the robot has some sort of path that it's following, or other autonomous decisions for its. But for the purposes of this workload, it was more about the computer vision. Yeah.
For applications where you can't have that PC hardware on your robot, is it possible to have your camera ship that data over to AWS, do analysis on AWS, and then ship it back, process it into AWS, and then give it back to the robot
So your question is, in situations where the robot is fully connected to the cloud, is it possible to send the video to the cloud, do inference in the cloud, and then send the decision back to the robot? Yeah, so that is possible to stream video into the cloud, and then you can do machine learning inference in the cloud, just like you would use SageMaker in any other workload, and then send that decision back to the robot. That would just involve more latency, right? Because you're sending to the cloud and then back to the robot, whereas here, everything's happening on the robot other than when models are being deployed or the data's being sent back to the cloud.
Sorry.
Yeah. No, please.
Could it be done on a complexity basis, sort of like a lot of self-driving cars? They come to a decision that they can't make using their kernel software. They kind of send it out to the cloud.
Yeah, so the question was, can it be done on a complexity basis? So can some decisions be done locally, but then maybe more complicated decisions be done in the cloud? Yeah, you could set up that logic maybe, based on the, percentage accuracy coming out, then send it to the cloud. Again, all of this is gonna involve more latency, right? Especially if you're looking locally and then saying, oh, not accurate enough, and then need to look in the cloud. I mean, it's not gonna be extremely, depends on your internet connection, but yeah, that's just adding more latency, but yeah, it is totally possible to do that. You would just have to create that logic, and that could be in its own component too, right? You could have another Lambda function in there.
With the 5G coming in, 5G becoming more and more popular, I thought everyone is moving towards that. Isn't that true, or everyone is concentrating on the decision on the edge, or we are looking at the cloud being the decision maker?
Okay, so the question was, with 5G coming in, is it that more people are taking advantage of sending things to the cloud over 5G versus doing something at the edge locally? Yeah, totally depends on the use case. A lot of robotics customers don't necessarily have that option or need very immediate decisions. And so locally is always going to be the fastest, no matter what. If you're sending data somewhere and then need data coming back, that's always going to take longer than if it's staying put. But yeah, there are going to be customers that are going to do that for sure.
For the image processor, usually machine learning model running time is take a while. So all the computation happens in the locally, or?
So the question was training the model and all the computation related to creating the model is a lot of compute power. Is that all happening locally? Is that right?
Yeah.
No, so that's all happening in the cloud. So with Greengrass, you're just deploying the final model for inference at the edge. And then you could send, if you want to still collect data, you can send that back for additional training. But the training itself is happening in the cloud. So that's kind of happening here, right? The SageMaker training jobs in SageMaker model registry. And there's a service, Amazon SageMaker Neo, that will optimize the model for the edge. And we even have public components related to that workflow with SageMaker Edge Manager. Any other questions? Yeah.
If the cloud is not available one way or another, and let's say there's multiple devices at the edge or working locally, can they still work together if it's part of a complete system until they can get that cloud access back again?
So if the cloud is not available, can multiple devices work together to make a decision? You're saying kind of like a gateway device, maybe something with like greater compute power?
I just mean, like, do they all stop doing what they're doing if they can't access the cloud? Can they still like talk with each other?
Okay, yeah, so can robots still communicate with each other when they're not connected to the cloud? Or yeah, so yeah, I actually don't have a slide on that, but yes, there is local communication between devices that can happen via MQTT or another communication protocol. And so you actually triggered, I know this wasn't your original question, but we do have some customers now who are using like a gateway device sometimes, where maybe something with stronger compute, or maybe their robots can't be connected to the cloud and just the gateway device will be. So there's a lot of interesting architectures coming now with that. And yeah, so to answer your question, yes, they can still communicate locally.
I was just curious, what's your typical host operating system?
Typical host operating system. Yeah, usually Linux, but we do see some Windows, but usually Linux. Yeah, I guess, do any of the people working with robots, what are you working with? I feel like there were 2 people who said they were? No? Okay. All right, anything else on this computer vision model here? Awesome. Okay, so let's go to the video streaming. Got to go back a bit, I believe. Yes, okay. So just a mini summary first. So WebRTC is an open technology specification for enabling real-time communication across browsers and mobile applications via simple APIs. And it uses peering techniques for the real-time data exchange. And so we have a service, Amazon Kinesis Video Streams with WebRTC, KVS with WebRTC, and it provides a standards-compliant WebRTC implementation as a fully managed capability. So you could use KVS with WebRTC implementation to securely live stream media or perform two-way audio or video interaction between any camera IoT device and WebRTC compliant mobile or web players. In the IoT space, for example, we have customers who are doing like baby monitors or home security cameras, things like that could use KVS with WebRTC. And so as a fully managed solution, you don't have to build, operate, or scale any WebRTC-related cloud infrastructure like signaling or media relay servers. You could securely stream media across applications and devices. So let me move forward here. OK, so KVS with WebRTC is used in robotics frequently for teleoperation or remote command and control. So maybe your robot got stuck. You can't work autonomously right now. You want someone to remotely control your robot. You need something that's low latency here, because if you start controlling your robot and then it only happens a few seconds later, that's not going to work. So that's where KVS with WebRTC comes in. So to discuss the setup here. So in this case, we're going to have green grass on the robot. And we're going to deploy the solution via a Docker container. And you could store that container in Amazon ECR, Elastic Container Repository, in a registry there. And that will then get deployed to your robot via Greengrass. And so here's the solution container. And you could give it the container the proper permission so the camera can access it. And then the user is going to say, OK, I want to start teleoperating. They're going to request a WebRTC connection from the browser. And then, where are we? OK. Then what's going to happen is the signaling, the WebRTC, KVS with WebRTC signaling channel is going to go through Greengrass to the cloud to handle the permissions and the credentials. And then your video channel is going to go back to the browser. So I guess just do like a mini version here. What's important is that, so KVS with WebRTC, oh gosh, we're going to start that over. KVS WebRTC, right? So you have your browser here, and then you've got your robot here. And so and this is running Greengrass v2. And so what's happening is your camera on your robot, the video stream or the media stream is going to go directly to the browser. But the signaling channel is going to go through Greengrass to the cloud. I apologize for my great drawing here. This is the signaling channel here. And so this helps with latency because the media stream is not going to the cloud to your browser. It's going directly to the browser to the person who's viewing the video stream. And I'm going to come back to this slide, but I'm going to compare it to the next slide, which is more for video, Amazon KVS without WebRTC, so for video recording at the edge. So maybe you're recording some videos and then maybe you want them later for machine learning training. Or maybe you just want a human operator to look over what the robot did. So here, again, we're deploying the solution from ECR in a container to your robot with Greengrass. And again, Greengrass is handling the credentials. But here, the video stream is going to Kinesis video streams, and then you could play it back through a browser. So higher latency solution, but it's different purpose. It's for video recording. And so, yeah, that's coming from videos saved from the camera onto your device, and then you could request specific videos in this case. So in mini version, let's see if I could. OK, we'll just start over. OK, so in mini version here, KVS, and then we've got the robot. And it's running Greengrass v2. And you've got the video on the disk. And so this is going both the signaling channel and handling the permissions and the media are going through to KVS, and then you could access KVS to view the video. All right. Any questions on those two different use cases? Yeah, in the back.
To reduce latency, could you not parallel stream to browser as well as to the...
Sorry, one more time.
To reduce latency, so this is a high latency solution, right?
Higher latency, yes.
So can you not parallelly stream to browser as well as to the video stream?
Yeah, so the question was, can you stream to both the browser and to KVS? So different use cases. So if you have a robot that has both use cases, you can do both. Yeah, you can have live video where you're using KVS with WebRTC, let's say for teleoperation, and then you want some video stored and you could go through KVS. Yeah, that is an option. Did that answer your question? Okay. Any other questions? All right, so I guess one other thing I didn't mention on the previous slide. So yeah, so for teleoperation with KVS, you could also send data back. So right, if it's teleoperation, you also want to be sending commands to the robot. So you're getting shown the video, and then you want to send commands back. So that can happen through that same data channel through WebRTC. All right, if there are no other questions, the last topic I was going to discuss was related to how you could use ROS on your with Greengrass and the different options you have. Okay, so as I mentioned, ROS is the robot operating system, so it's very commonly used for robotics companies, both ROS1 and ROS2. And so when you're deploying to Greengrass, you have a few different options. So you want to decompose your overall ROS application into a set of services that could be delivered as Greengrass components. And this is kind of the one we were discussing the most at the beginning here, where each ROS application or service is going to be its own component. And then they can communicate over a ROS messaging layer. And then just Greengrass is deployed on your robot, and then can communicate back up to the cloud. Another good thing to do here is to have one component that's your ROS stack, where you have your ROS packages bundled. And that way, these could be more your actual applications here. And then, so one of these components here, let's see which one. I don't think it's shown here, but these components can contain a ROS node that uses the AWS IoT Device SDK to stream ROS topic messages over MQTT into AWS. And using Greengrass makes this easy because the Edge Runtime Manager handles the AWS credentials with the required X509 certificates to securely connect to the cloud. I guess one other thing I want to mention is we do have cloud ROS extensions to specifically handle common use cases for ROS with AWS. So for example, we have an extension that lets you stream ROS logs into Amazon CloudWatch logs or data from ROS into Amazon S3. And so you can then download those as components on your robot through Greengrass. So another option you have is to deploy your ROS applications and the associated dependencies as Docker containers. And so in this approach, you would still decompose your ROS applications into these services. And then you would store each of the built container images in Amazon ECR. And then your Greengrass component would pull from ECR. Oh, here we are. Pull from ECR onto your robot. You also can use Docker Compose, and that would just get stored in Amazon S3. And then you could call Docker Compose up to run your containers on your robot. And even when you're using Docker containers, the AWS credentials still could be passed to the raw services, and you would just do that via environment variables in your Docker container. Are there any questions between this architecture and the last one? And then there's one more option. Okay, let me go to the last option here. So you might already be using containers on your robot and maybe even selected a different container orchestration tool, something like MicroK8s. And so this final pattern, while it's similar to the last pattern, and both are deploying raw applications and containers, but here we're actually deploying Greengrass in a container on your robot. And so instead of it being on the host, it's in the container. And then this lets you encapsulate the cloud layer, including the pre-built public components within a container, and still connect to components running in the Greengrass container to your ROS computational graph. Yes, so any questions between any of those three slides on like the different options?
How much more memory does that require?
Running it in, so the question was, how much more memory does it require? And you're saying running it in a Docker container versus outside? Or
Greengrass in a container on the device.
So it's not gonna, let me think. So if it's running in a Docker container, well, one reason why running it in a Docker container is nice is you can kind of restrict compute for your Docker container. I don't know the difference in how much compute it takes running in a Docker container versus not, but if you come to me after, I could look into that for you. Anything else? Those are all the slides I had, but I'm curious if there are any other questions or workloads in robotics that you would want to discuss. Yeah.
Another question, any other examples of customers, robots that are available?
Yeah, so the question was any other examples of customers that have developed with AWS robotics customers? Yeah, so another example is Seafloor Robotics, and they build robotic boats for like different research purposes and other purposes as well. So they have like thousands of robotic boats deployed on the ocean. So another use case where remote connectivity is an issue. And then, yeah, we're working with a few other agriculture companies, and then what other industries do we have? And then in the fulfillment center, industrial type robotics industries as well. And yeah, I think a lot of them are considering Greengrass. A bunch of them are using Greengrass, and some more are considering Greengrass because of these features for deployments, the conditional updates, and the way that it could run without connection, and then machine learning inference on the edge, and all these benefits. And then a lot of them are then connecting that to front-end web applications for their users. Yeah.
Have you seen the case where people use Greengrass as a Yotta layer?
So the question was, have we seen examples where people are using Greengrass as a Yotta layer? Instead of a container? I saw one customer do it. I don't remember the details, unfortunately. I wasn't super involved, but there was one customer that was working on that. And I could get more information if that's something you're interested in digging deeper into.
Your
I honestly, I don't know offhand if they ended up going with that option because I wasn't super involved with that customer, but I could definitely look into that for you. I would imagine it would be, I mean, it's just another, it's a runtime, so you can deploy it in other ways. What limitations that might produce that, I don't know offhand. I know when you're running it through Docker, for example, like you could still run all the pre-built public components, but you have to like set a certain configuration so they don't run in container mode because that's one of the options. And same with Lambda functions. They could run Lambda function containers. They could run when you have this running in a Docker container, but again, you need to run it like not in container mode. So it could be similar to that.
Why did y'all call it green grass?
That's a great question. So the question was, why do we call it greengrass? I actually do not know. This is greengrass version 2, and I was not around during greengrass v1, so I don't know why they named it
I
that.
was just trying to look it up, and it's actually green grass. Like I see green grass, so I'm trying to like look up your company, but it's giving me pictures of green grass.
It would be under AWS IoT Greengrass, and V2 is the one we were talking about today. We've come up with a lot of enhanced features over V1 and a lot of benefits in how you deploy with these components. Sure. Yeah.
Are there any recipes available in GitHub or something like that?
Yeah.
On ROS?
Yeah. Are there any recipes available on GitHub for ROS on Greengrass? Yes, I know of at least one. We have an AWS Robotics blog, and we have one blog on, at least one blog, maybe multiple, on deploying ROS in components on Greengrass, and the recipe file are available on GitHub from that. Awesome. Well, that is all I have. If there are no other questions, yeah, thank you so much for coming out. And I guess first, as I mentioned, I used to work for training and certification. We've got a lot of great courses on AWS Skills Builder. I also recommend working on getting some of those certifications. They're great for learning. And thank you so much. And please complete the citizen survey. Yeah, go ahead.
I had a question. Is there a certification
For robotics? No, there's no certification for robotics at this time, unfortunately. We do have a machine learning one, though.